What's up guys, Mr. Steckler here. In this lesson, we're going to learn about 3 types of problems. Well-structured problems, complex problems, and wicked problems. So what makes a problem well-structured? A problem is well-structured when there is a best solution to that problem. For example, when you're solving a math question, x plus 3 equals 10. There is a best way to solve it, a fastest way. Look at the left side, look at the right side. When is this equal? When x is 7. 7 plus 3 is 10. The best way, the fastest way, is just deducing this is true as an equation. When 10 equals 10, when x is 7, it's well structured. There's a fastest way to do it. You also could have subtracted 3, and gotten x equals 7. That way works too, but it's not the fastest way. A well-structured problem is well-structured when there is a best solution. Now it's time for complex problems. Complex problem is something that you can go on Google, you can find an answer, but you may not find the best answer. What do I mean, no best answer? So one complex problem is, what is the best way to get to school? Well, you may not know based on traffic and many other factors, so there may not be a best way to get to school every single day. So it's complex because there's multiple different ways in which things can branch off during the process. Another complex problem is fundraising. To fundraise money towards getting some sort of project, there's not necessarily a best platform to use, whether it's an online fundraiser, you sell cookies, you sell products, there's lots of ways to fundraise. It's complex to do because there's no best answer. All right guys, the last and hardest type of problem is a wicked problem. So this type of problem is tricky because you don't necessarily know how to solve it until it's already been solved, and when it's solved, it's not permanently solved. For example, what is the best technology to help students learn? Well, let's pretend it was the Apple Pencil. Right now, if we were to go in, invest, get everyone an Apple Pencil, and we were to have huge success with it, it might be the best tool to help students learn, but it's really complicated to prove it. So for example, what can the Apple Pencil solve? Most people don't know what it can solve, but feel like it's a powerful tool. So the goal is not clearly defined, what can it really do? It also might not always be the best tool. 100 years from now, they might have this crazy device that's the best tool in education. So it's not always the best. It might be the best today, but because it's not always going to be the best, it makes it wicked. Also important to note, wicked problems are not ever done. They're either better or worse. So something can be always improved. So one more example for wicked problem. How do we stop world hunger? Well, world hunger is a really complicated problem, right? There's so many factors to it. And if you stop hunger in one country, maybe you create more hunger in another country, because if you take all the food and bring it to this spot, there are going to be repercussions. If you give all the food to people in one place, you're taking it from somewhere else. Or let's say that we provide a ton of food to one country, and because we give a lot of food to them, they can eat. But then because they're relying on us, they stop their hunting practices and they start relying on us, and we end up making it worse. There's so many things that can happen. The goal of it is to stop it. But how do we even start stopping the goal? If we try and fix the problem itself, maybe we create a new problem. And it's very confusing to see what the way you solve this type of problem is. I don't think that world hunger will ever be solved, simply because it's an interactive problem that if one thing changes, another thing changes too. And when you have all these moving parts and goals are hard to figure out, that's a wicked problem. All right, so you might be wondering, why am I learning about wicked problems? And well-structured and complex. And that's a great question. So you guys are going to end up building these Clawbots over here in groups. And what you're going to do is you guys are going to learn how to program them, and you're going to get to see the code work in action. Oh boy. And in these groups, you guys are going to be learning how to code. You're going to be solving real-world problems. So in this class, you guys are going to have to figure out which problems are the most authentic, most worthwhile ones to work on. And wicked problems are ones that are way beyond our scope in this class. But we're going to focus a lot on complex problems, problems that you can't Google. Because if you can solve something on Google, yeah, it's important to know. You should know math so that you can do things in the future. World War II would have been lost if not for algebra. Two-step equations with system of equations helped us defeat the German code-breaking machine, which helped us win the war. Yeah, math can be important. But if you need to learn that, you could literally go on Google and get everything. Important to know? Yeah, but Google can answer it. We want to focus on things that Google cannot answer. In other words, something that is a complex problem. And the only way we're going to be able to actually attack these complex problems is by asking good questions. So a lot of this class is going to be on problem solving, learning how to ask good questions, and working in groups and collaborating. So let's do it.